Hello, welcome back to my channel. In this part 2 of the video, we're going to go through the Primary 5 Science End of Year Exam 2021 from Eunos Primary School. Now, if you have not watched part 1, which is from question 1 to question 14, which examines the life science question, please go ahead and check it out. In this second half of the video, we'll be going through the physical science portion of the MCQ questions. Let's get started. Now, this is a very common question that comes out over almost every year in PSLE, so do learn how to tackle such questions. The table shows the melting point and boiling point of three different substances, A, B, and C. Now, which of the following is correct when the temperature of the substance is at 50 degrees Celsius? Now, what's important in this part? Let me just give you a simple example. Let's take a look at water, right? For water, 0 degrees Celsius is the melting point. 100 degrees Celsius is the boiling point. So anytime water is underneath 0 degrees Celsius, you know for sure that it's ice, which is in the solid state. And if water is above 100 degrees Celsius, you know for sure it is steam, alright, or it's in the gaseous state. So therefore, when water is in between 0 and 100, you know for sure here it is just simply water and it's in the liquid state. Having understood this, let's take a look at. So anything beneath here should be solid. In between here, between melting and boiling, should be liquid. And above here would be gas. After we have done so, let's situate where is 50 degrees. Where is 50 degrees here for A? 50 degrees is here. Where is 50 degrees here for B? Well, 50 degrees is here also, degrees Celsius. And 50 degrees Celsius for C will be here. Right? 50, then to 60, then to 700, right? 40, then to 50 to 200, 40 to 50 to 310. Therefore, for substance A, it is a liquid at 50 degrees Celsius. For B, it is also a liquid at 50 degrees Celsius. For C, it is a solid at 50 degrees Celsius. Because the melting point has a different name, it is also known as the freezing point. So when water freezes or when a liquid freezes, it will become a solid. So what is the correct observation? Let's check. A is in a solid state, that is wrong, should be liquid. B is in a liquid state, that is correct. C is in a gaseous state, that is wrong. B and C are in solid state, that is wrong. Only C is in a solid state, so this is wrong. Answer for question 15 is 2. Let's go to the next one. Water cycle question. Study the water cycle here. Now, clouds are actually in the liquid state. These are all just tiny water droplets in case you have forgotten. Clouds are in the liquid state. This is simply water. So water must have evaporated. Now, for it to evaporate, it must have gain heat. Right, that's the purpose of the sun, to allow heat to be sent over from the sun to the earth, and when water gains heat, it will evaporate. And when the water evaporate into what? Into water vapor. And when water vapor turns into liquid, it's a process where heat is lost, and this process is called condensation. And where's the cooler surface? That will be higher in the air, and the air above, higher in the air, is always very cold. So which of the following shows the correct state of water and the processes? So state tells you, is it liquid or solid state? Okay, so at P, this is water vapor, that's the gaseous state. So P must be gas. Q is a cloud. Cloud is liquid, right? Tiny water droplets, so Q is liquid. So answer is really number 1. Of course, we will check the rest to see. This question make it easy for you because you don't even have to look at the processor to get the answer. Just take a look at this. A harder question will require you to process more information. So process X is evaporation. Yeah, process X is evaporation. And Y here is condensation. So Y is condensation. So answer is 1. Question 17. A glass beaker containing boiling water was left on the table. boiling water, that's at 100 degrees Celsius. In a room, so if this is at 100 degrees Celsius, and room temperature, let's say, is at 30 degrees Celsius, heat will be lost from the hot water to the surroundings. Alright? Now, how can you speed up the rate of heat loss? How can you cool the boiling water even faster? Well, this one works. If you put a metal spoon in the water, well, the metal is a good conductor of heat. So heat will be conducted through the metal spoon away into the surroundings. This will help. Now, covering it with a wooden lid will not help, because firstly, wood is a poor conductor of heat. If you cover it with a wooden lid, you are actually slowing down the heat loss to the environment. So B is wrong. So anything with B, so sorry, that is wrong. I need to check what C. Wrap the beaker with a cloth that's wet with tap water. So what happens with tap water? Well, water will gain heat from the hot water inside, and when it gains heat, it will evaporate. This whole thing will mean that it is taking heat away from the hot water, therefore helping it to lose heat even faster. So both A and C helps. So answer is number 3 for this question. Next one. This is about mass. Matter has mass question. So there are 2 experiments here. Now this 20 gram is the mass of the beaker and the water. This 500 gram is the mass of the cotton wool and the beaker. Alright, strange, this is quite a heavy thing, right? So Eric can conclude that liquid Z and cotton wool has what? Alright, now the volume is the same. You can see from the labeling here. When it comes to any diagram, it's important to understand the diagram and the labels. These are called labels. They are there to help you understand it. So, and this unit, cubic centimeter, is the unit for volume. And both the volume of the cotton wool and the water is the same. So they have the same volume. So we know that 2 and 3 must be, the answer must be either 2 or 3. When it says different volume, that's wrong. Different volume, that's wrong. Okay? Now let's check whether the mass is the same or not. Now, clearly the mass is different. So this liquid has very little mass apparently. This cotton wool has a lot of mass. Alright, 500 grams, 200 grams. So here, the mass is different. Okay? If the mass is the same, then both will show either 20 grams or both will show 500 grams, which is not the case. So answer is number 3. Next one, electrical system question. This is something that you learned in term 4 this year. So let's take a look. So which of the setup will both bulbs light up? Now you know the structure of a bulb, right? A quick recap for you. So there is a metal filament inside here. Alright, this metal filament touches this portion. This part is called the metal tip. This part here is the metal casing, and this is of course the filament. It's made of a material known as tungsten. Now this is your glass bulb, and of course you know that glass is an insulator of electricity. Current cannot flow through the bulb. Now metal is a conductor of electricity, and if it touches metal, current can flow through. Alright? Now let's carry on and let's see. So for the current to flow, let's say we have a battery here. For current to flow, I must flow through the filament. I repeat, for current to flow through the filament, the one wire must touch the casing, the other wire must touch the tip. Then current will flow through the metal tip, flow up the tungsten filament, down through the casing, back to the battery. This is how current will be flowing. Now I can actually touch metal casing only. For example, new wire like this. Is current flowing through this green color wire? The answer is yes. Current can flow, touch the metal casing, flow through the metal casing and back. This wire, green wire, becomes very hot, but the bulb will not light up because the current doesn't flow through the filament. Okay, know this difference. Current can flow, but it doesn't flow through the filament, so this bulb does not light up if I connect it with the green colored wire. Let's check here. Touches tip, touches casing, this bulb lights up. Touches tip, touches casing, this bulb lights up. So for number 19, alright, I know that both bulb lights up. Let's check B now. Touches metal casing, touches metal tip, this bulb lights up. Touches casing and casing but doesn't touch the tip, so this bulb does not light up. So only one bulb light up in this case. Alright, so anything with B is wrong. Wrong, wrong, wrong. And that's your answer. Let's triple check. Touches metal casing, touches metal tip, this bulb lights up. Touches metal casing, touches metal casing, current can flow through, but this bulb does not light up. Touches metal tip, touches metal casing, touches metal tip, touches metal casing, current flow from plus to the minus. Yep, this one both will light up. So A and D is the answer. Now a magnet question. A bar magnet was tied to a string and hung onto a retort stand as shown. A compass was placed near magnet X to show the direction that it was facing. Many of my students ignore this clue, which is unfortunate because this is an important clue. This tells you that the compass, which itself is a tiny magnet, is pointing towards the north direction. So this is north. That tells you therefore if this part here is north. Okay, if this part is north, this part will be south. We move away means that these two are actually repelling each other. Repel, then this part must be a like pole. Alright, because you learned that like poles repel. S and S, south and south, they are the same, they are like, they repel. If this is south, this is north. So Q must be north, and then at P must be south. So the answer is 4 for question 20. Next one, this one is about some heat flow question. Now before we go on, let me just teach you a statement that works all the time. Okay, you can copy this down. A poor conductor of heat is very important. Why? Because it keeps, number one, hot things hot, and it also keeps cold things cold. I repeat, a poor conductor of heat keeps hot things hot, keep cold things cold. So for example, let's say I have a container here, same container here. The container A and B are the same. In A, I put in some hot soup at 80 degrees Celsius. In B, I put in some ice, okay, at 0 degrees Celsius. I seal up both of the containers. And both containers are made of this special material called poor conductor of heat. Alright, so, and they are placed in the same environment, so on the same table here. The surrounding temperature, say, is 30 degrees Celsius. Now, for the ice to melt, heat must reach the ice. To reach the ice, heat from the surrounding must go through the poor conductor of heat. It can go through, but it will be very slow. So that's why this poor conductor of heat can keep these cold things cold for a long time. In this case here, the temperature of the liquid here is higher than the surroundings, so heat will want to be lost to the surroundings. But since this material is made of a poor conductor of heat, the heat loss from the hot liquid to the surrounding is slowed down. So therefore this poor conductor of heat will will keep the hot thing hot for a longer time, since the flow of heat to the surroundings is slowed down. That's why this statement is true all the time. A poor conductor of heat keeps hot things hot, cold things cold. And this understanding will help you lots of time when you do this question. Hot soup in material P, hot soup in material Q, hot soup in material S, hot soup in material R. This data here is to help you identify which material is the poor conductor of heat. Okay, the poor conductor of heat will let the soup inside reach the room temperature in the longest possible time. So therefore Q takes the longest time to reach room temperature. So Q is the poorest conductor of heat. And remember, the poor conductor of heat will keep hot things hot and cold things cold. So which material can make a container which keep cold water cold for a long time? If you can keep the hot things hot for the longest time, you can keep the cold water cold for the longest time. And therefore the answer for question 21 is Q. Next. There's a bit more and we'll come to the end of this video. Let's hang in there. Alright everyone? Jason set up a light sensor and a light source in a dark room as shown below. So light sensor is here. The light sensor will detect light that comes from, this is a light source, right? And light travel in a straight line. So it will shine light in all directions, including towards the light sensor. So the sensor detects the light, right? If this is the light intensity, well, you will detect a constant amount of light. But what happens when this guy Jason blocks the light when he is running over here? When his body is here, he blocks the light. Then instead of a straight line, then when he blocks the light, light cannot reach the sensor anymore. Then it will drop to 0. It will be at 0 for as long as it's blocking it. And once Jason moves past this, he runs here, blocks, and moves past it. Now the light can reach the sensor again. Then the sensor will detect light again. So this gap here is where Jason ran past the sensor, right? Ran in between the sensor and the light source once. So this then tells me he ran past it once, twice, thrice, 4 times. So based on the result, and in 1 minute, this is all under 1 minute. So how many times did Jason run across the length of the room in 1 minute? 1, 2, 3, 4. Just 4. For those who choose other answers, I'm not sure how you got the other numbers, but this is just a straightforward reading of this graph. Next one. This circuit here, after one of the bulbs had blown. When bulb blow, you know that means that the filament has fused. Filament has melted. So in the diagram here, right, the fusing, when this one fused, means that this part here melts. If it melts, then the filament will be dangling down, and what you will see will be a gap. Okay, what you'll see will be a gap, and when there's a gap, current cannot flow, and the bulb will not light up. So when bulb blows, it means the filament has melted, creating a gap, an open circuit that current cannot flow. When this thing happens, all the bulbs will not light up. So this bulb must be in the series part of it. So when P blows, there's a gap. There's a gap here, current cannot flow. I always start from the plus. Current try to flow through, cannot flow. There's a gap here. When current cannot flow through here, none of these will light up. So the answer is 1. Let's take a simple example. Let's say if I say I block this. Let's say R here is the one that blew. Can current still flow? Yes, it flows here. 2 bulbs can light up. What if S is the one that blew? Yeah, current can still light up. The bulb can still light up. Current can still flow here. This part is the closed circuit. This part is open now, so this bulb won't light up. But these 2 can light up. Right, they say when all the other bulbs do not light up. Next one, result. Set up a circuit as shown. All 5 bulbs were lit when all 4 switches were closed. Rizal wanted the least number of bulbs to be lit by opening only 1 switch. He wanted the least number of bulbs. So there are 2 conditions here. Open only 1 switch, which can create a gap only in one of the switches. Which switch should it open? Usually I like to just use my finger or a 5-cent coin, just block off one of the switches just to see for myself. So I don't have a coin here, I use my pen cap. Let's say if I open A, means I make A a gap. If A is a gap, then how many bulbs can light up? This side of course can't light up anymore, these two, because current cannot flow through this open circuit. But current can still flow through here, can still flow through here. I see have 3 bulbs being lighted up. Let's try to open B instead. If now I close A and open B, now current can flow through this circuit here. So 2 bulbs are lighted up. Current can flow through here or not? Cannot. There's a gap. Can current flow through here? No, there's a gap. So here 2 bulbs will be lighted up. What if I were to close this part here, C? The close C, my cap is too big. That's why I say use a 5-cent coin. My cap is too big here. I have an eraser. Use an eraser. Let's see if it helps. Okay. Then of course the bulb in the center here will not light up anymore. But this current can still flow through this closed circuit. These 2 will light up. Current can still flow through. You see here on top. Current can still flow through here. So actually 4 bulbs will light up in this case. Lastly, if I were to close D, what happens? Well, current will flow through here in this closed circuit. Current will flow through here. So 3 bulbs will light up. So based on what we have observed and interpreted, which switch should he open so the least number of bulbs will be lit? And the answer for 24 is 2. Just 4 more questions. Now, Selvi blew air into a balloon and tied it tightly. Now, after leaving the balloon in the refrigerator for a few hours, she observed the balloon was smaller than before. Okay, so there's air here. This one is about heat flow, and matter expands when heated, matter contracts when cooled. She observed the balloon was smaller, so definitely the air must have contracted. Air contracted when cooled. Now, by the way, we hear screeching. That's because my birds, Blue and Barry, a pair of lovebirds, are screeching in the background. They love to do this in the morning, behaving like chickens maybe. When chicken crow in the morning. Haha, lame joke. Okay, let's come back to this. So, heat flow, for it to contract when cooled, it means that it must have lost heat. Air must have lost heat. If air lost heat, where did it lose it to? Lost it to the cooler environment. And where is the cooler environment? That's in the refrigerator. Okay, so heat must have flowed from the air in the balloon or not to the material of the balloon. This part is kind of weird, alright, but this one is true. Because which part got cooled down first? The material cooled first. Okay, so this is the most likely answer. Let's take a look at the other options. Heat flow from refrigerator to the air. That's wrong. Refrigerator is cooler than the air. Heat always flows from a place of higher temperature to lower temperature. How can heat flow from lower temperature place to a higher temperature place? This is wrong. Same thing, the material was taken from the room. So the material of the balloon was at room temperature at first, let's say at 30 for example. And refrigerator was cooler, let's say at 0 degrees Celsius. Heat must be flowing in this direction, not that direction. So this is wrong. Heat from a material balloon to the air in the balloon. Well, this is not true because both of these things are at the same temperature at first. And after being in the fridge for a while, the balloon will have a lower temperature because it touches the cold air in the refrigerator. Then this will become higher temperature. Heat will flow this way, not this way. The preposition here is important. From which place to which place. This is wrong. So this is the best possible answer. Number 26 is about light and shadow. If I have a light source, to cast this shadow, this bulb must be lit. So light shines here, blocked by this wooden stick, so cast a shadow. This bulb must be lit. So light shines here, blocked by this, and cast this shadow. So the answer for this is B and C. Excuse me. Last two questions. Now, Maria tested 3 types of string A, B, and C by hanging weights from each string. She increased the weights until the string broke. There's a condition, until the string broke. If it broke, it means that the weights are more than what the string can handle. Like for example, this string can handle 3 kg. Anything beyond this one will break. B can handle up to 5 kg. Anything beyond 5 kg, this will break. C can handle 7 kg. Anything beyond 7 kg, C will break. So, in order to hang the most number of weights, I must have the one right at the top here to be the one that can handle the most weights without breaking. Alright, because this one, if I put this here, it means it must handle 3 weights, right? Okay, so anything that is not C will be wrong straight away. So that's how I see this, and that narrow down to either 1 or 3 here. Now let's see, if I total this up, 3 plus 1 plus 3 is 7. Just nice. C can handle 7 kg. The total here is 7 kg. 1 is the answer. What if you chose this? If you chose this, okay, what happens is, well, let's check. 1 plus 2 plus 3 is fine. It's 6 kg. Yes, can handle. Now let's check what else can be wrong. So here B is here. For B to break, these two must exceed 5 kg. This two is just 4 kg. It's less than 5, so B won't break. A is handling 3 kg. A won't break. Therefore, I confirm this is the answer 1. How about this? Here A is trying to hang on to 5 kg, But can A hang on to 5 kg without breaking? No. A will tear and break once it exceeds 3 kg. So this part here is wrong for A. Answer for 27 is number 1. Last question, another electrical system question. A game was built using a battery and 3 light bulb holders. Okay. Now this is your circuit card thing. The wires were hidden behind the card such that only the bulb holders could be seen. I'm not sure how the wires are connected at the back. Now the clue are given here. Bulbs, we look at those that are lit up. Okay. When no bulb were at J, which means there's a gap. When they remove the bulb from J, that means J is a gap. When there's a gap, K and L can still light up. Okay, so which means the wires are connected definitely to K and L. So when there's no bulb at K, J and L can light up. So I look at these 2 clues first. Let's take a look. So let's say if there's no bulb at J, so I will now make this a cover J, which means J is not there. These 2 can light up, right? Current can flow through L and to K. So I fulfill this condition. K and L can light up. How about if I remove K? I remove K, so I need a cap to cover it. Okay, I move K. I move K, can the J and L light up? Let's check. Current can flow through L and flow through J. Yeah, this is true. So this one works for J and with no bulb J and K. What if I remove L, like it says here? When I remove L, alright, current can flow or not? No, it can't flow through anymore. There's a gap, can't flow through. So these 2 bulbs will not light up. So that's why 1 is the answer. Okay, that's all for the physical science part of this paper. I hope this helps you in your revision. All the best. I'll see you in the next video.